Here at the Rottler F69A with Embry Harrick. Embry, this machine, incredible. We've got the block loaded up. It's a brand new block, but that doesn't mean we're ready to put parts in it. We've got some work to do to make it perfect. And we're going to walk through some of the steps. Now, I want everybody to know you're going to have a chance to ask some questions in just a little bit. So start thinking about that now. Embry, tell us a little bit about what goes into this, and we'll go through it step by step.
Sure. This is the Dart LS Next block, and it was chosen for the show for the giveaway. The first thing that we do when we get a block, we take it out of the box, we put it in, torque the mains in place, then we take our line bore gauge and check it to make sure it is a correct spec. Secondly, we put it on, make sure the machine is indexed in. We put it on the machine. We have a probe. We probe the surfaces of the deck on both sides to make sure if we need to remove material, correct it, whatever needs to be. The next step, we also use the probe to go in and locate the cylinders to see if they're in proper location for our blueprint specs. After this is done, then our operator, Mr. Logan Miles, puts it into the machine, hits the program, and off we're running.
So some people might be thinking, like, well, wait a second, we put all this effort into selecting a block. Why do we need to go back and check what it is? This thing is brand new. And the fact of the matter is it's a cast block, and it's really great compared to the past, but you have to find out what you're dealing with first, what you have, and then go through the process. And from what I understand, and you had a great analogy, the block is your foundation, and if you get something wrong now, you may not even be able to go back and fix it in the future. And so these are things people need to consider.
Yes, each engine builder has its own specifications that they like to work with. I call this the block because it's like playing with blocks. You start off with the block first and you build from that point. Clearances are different. Applications are different. It depends on if it's naturally aspirated, a power adder. So you have to take in all those factors too. And even though Dart does a great job with these, there may be a little bit of core shift, not much if any. You may need to correct the cylinders by thousandths to 2,000ths. At this point, we have that opportunity to do so, so we're going to put it into the specifications that we see that are needed at this time. And
seeing the lifter bores and the bushings, and it's just the evolution of engine building, so many different areas that maybe someone didn't even think about now are able to be taken and made perfect.
Exactly, yes. Now, at this point, we did put the lifter bore bushings in this, and they are the keyway lifters. That is to index the lifters to the camshaft properly. And if we needed to change the geometry a little bit, the angles, we can do so at this point. It's pretty much with this machine, the F69A, you can about move anything in any location that you need to move it into for your own personal preferences.
And you guys at CNC Blockworks, it's got to be amazing to you to see the evolution of a machine like this and all the different things you're able to do that maybe once upon a time you had to live with and now you can make right.
Yes, I've followed this machine probably for the last 5 years, and I kicked it around for 2 years before I actually did anything. And to be truthful with you, it was a little overwhelming at first to me, but at the same time, after having some time and experience with it, I can't ask for anything better.
Well, and I think that's what everybody who's having a high-performance engine built wants to hear from their machinist, is that they can't ask for anything better. But I know everybody's excited about us, by the machine, talking about it, going through the process, building the engine. Once again, I want everybody to get your questions ready. We're going to have a question and answer session coming up. That way people will be able to really dig deep and find out what they want to find out. But in the meantime, we are now going to see this machine in action. So check this out.
Hi, my name's Tony Bischoff. I started BES Racing Engines. Actually, it was called Bischoff Engine Service in 1985. Started just with me, then I hired one guy, and then 35 years later we got almost 20 people working here. So. It was just me and myself, and we had a Van Norman 777 portable boring bar. I honed cylinders by hand with a Sun and hand hone where we used the AN stones on them. So that was all done by hand in a tank by by hand, that really worked your shoulder muscles pretty good. So, and we had I don't remember, we had an old broach to surface heads with, and a Peterson dry grinder, which we still have today. And that old thing's amazing. Amazing what you can make flat with an old stone. So, and we did valve jobs by hand with Sioux grinding stones. Well, we had a hot tank, we just built a tank ourselves with heating elements in it, and we used caustic in there. Boy, that was some smelly stuff. I don't miss those days at all. Ooh, that was horrible. Back then, we did mainly stock rebuilds, so we eventually bought an oven system from Ampro. I don't know, that's been a long time ago, which we still have today, which was great for cleaning really old, dirty, grungy stuff. So you baked the grease off, and then you shot blasted it, and it made it look like brand new, which worked real good for the stock rebuild stuff, to make it look good. Then we progressed up to probably a Peterson jet washers and stuff like that. We still final scrubbed blocks by hand. Today we run everything pretty well. When it's really dirty, we run it through a jet washer, and I use sonic cleaners to final clean. That's primary because they get stuff really clean, really cleans the pores out well, and that really sped us up a lot and made us a much cleaner product. Well, we went towards high performance because that's where the market went. It got too hard to compete with engine remanufacturers, so you couldn't really be profitable rebuilding stock engines one off at a time. And it's not near as fun as doing a high performance engine. So we started doing high performance engines, and wherever my customers raced and we raced, we done really well. And when you win, you gain customers. So that's kind of how we did. We started off really pretty heavy in the NMCA stuff in the mid-1990s probably, and our stuff did very well. There wasn't unusual when you went to one of them races. They might be 8 classes there, and 5 of them had our winners in the winner's circle. So that's really what helped project me up. And then as we went and we started doing truck pulling stuff and tractor pulling stuff, and everything we do, we put 100% in, and when they win, it shows, and it keeps you busy. And that's really how we progressed into the racing world. We updated to the Rottler F69A block machine, which allowed us to deck and bore blocks, in an hour, taking your time. And you can clearance for rotating assemblies. You can bore for lifter bore bushings and move lifter bores around. It really just gave you the ability to machine blocks much faster. After we lift the boards, we had to send them out to somebody else, which takes a lot of time. Spend a lot of money in shipping, and you can't make no money doing that.
My name is Brian Tell. Been a block machinist here at BES Racing Engines. Been here for about 6 years. Got about 10 years experience kind of in this background. Machining away. This is probably a 2016, 2017 model LT4. Putting aftermarket Darton sleeves in it, the flange sleeve. Well, once these sleeves are out, because that's usually the hardest part, is because you're going from roughly, I think it's about 4055, 4060 bore. I don't really know what the standard bore size is. It's around there. Boring them out, usually right now it's around 4-inch 240. That's when they start popping out. The bad thing is since they're cast in, they want to break. Sometimes they'll break the cutters. It's just there's nothing you can really do about it. But once they're all out, they'll usually pop loose and spin. You can get them all out, as you can see here. I'll bore to, since the sleeve's 4300, I'm going to put about 2/1000 press on them.
Okay.
So I'll get the bores finished, and then I will surface the decks. I usually do just a small cut on these LS's. I'll cut the counter bores, and that's pretty much it for, I'll get it cleaned. I'll deburr it and stuff, but
Sure.
as far as that in the machine work, it's a done deal. It's ready to set these flange sleeves that we're going to use. So. Oh yeah, this machine's great, man. I mean, doing it on like the old style, boring bars, I mean, it was really an all-day job. This is kind of knocks it down to, man, about 3.5 hours. And it's a done deal. The sleeve that we're going to use in this is 4300 OD, so I'll bore these to about 4-inch 298. I'm the dedicated block machinist guy, and before we'd all get a job, and from start it would be do our own thing, and then but now it's I do all the blocks, all the other guys. We got like 6 assembly guys, so I kind of keep them busy. And usually like these sleeve jobs, I kind of like them because the cycle time's a little longer, so I can have blocks honing. I got some lifter bushing jobs I got to do, and it makes it nice because it kind of does its own thing, and I ain't got to stand there and center up each hole because I've already probed this thing out and got it indicated in. It's just, what I mean, you can just walk away. Same deal with the hone down there with it goes from cylinder to cylinder. I mean, I can do 3 things, versus just, man, I'm boring a block right now. If I got something like if I'm sleeving this, and I got something, if I'm honing 6-7 thousandths out, I can line hone something, or what I mean. So yeah, it definitely increases the productivity, so. This is my setup for boring cam tunnels. This is a big block Ford. I'm going with a 60 millimeter roller cam bearing in it. Right now it's not cutting right now because I'm actually cutting between each journal. I still do a kind of a relief cut to make sure that the cam bearings ain't getting pressed in the whole time. So I do a relief cut between them. This way works pretty good. I don't actually bore them to size. I usually leave about 5 to 6 to hone out. And cutting them this way, I interpolate them. I can make about 100 thousandths cut per pass, so it works pretty good. I've probably done, I'd say probably a couple hundred. You know what I mean? I give or take, I've done a lot of them. You know, I will stone off the bell housing, because you standing it up on the bell housing, so you're basically going to find out if your mains is true to the bell housing. Sometimes, 9 times out of 10, I could swing these mains and they are within 1. And if I'm that over that distance, you're doing really good. I'll indicate, make sure that this is true here. I'll swing my mains, and this is a big block Ford. I'll stick the cap back on there. I'll check the center height, because this is 6078 on this one. So I'll verify that. 0, and then I'll just go ahead and 0 it right there in the cam bore, and then let her eat. Usually get about half the block done, and then I will unbolt the cap, leave this. I got a little puck here that kind of centers it, so it's kind of like a pivot point. I leave that bolted up the whole time, and then I'll flip the block around, basically do the same procedure, and swing it, and then indicate it in, and then I'll go back through and I'll check it. And like I said, 9 times out of 10, everything's good to go. I've found some blocks that have been previously bored by other people where they wasn't in center, and so I'll refix it, and that's pretty much it.
Welcome today. Thank you for coming to Robert Yates Racing Engines here in Mooresville. For everybody, I'm Doug Yates, CEO of Robert Yates Racing Engines. Here at this facility, we build all the FR9 engines that we race with all the Ford teams in the Cup and Xfinity Series. And we're having a fantastic year this year. At our other facility across town, we manufacture parts for our race engines as well as the aerospace and defense market. So Robert Yates is involved in a lot of things, but primarily the history goes back with my dad, Robert Yates, and our partner, Jack Roush, to building engines and racing cars and the NASCAR series. And we're proud to carry that on today with Robert Yates Racing Engines. So in 2012, we began our partnership and we put in a block machine, the F69A. And at that time, we were doing a lot of dirt late model engines, the RY45 engine. We were building all kinds of engines, and we just fell in love with the machine. It was very versatile, did great work for us, and we just really enjoyed the partnership and what the machine was doing. From there, Ford Motor Company came to us and said, hey, we want to go back and race Le Mans. We want to take the EcoBoost engine that's in our trucks, our F-150s, our Navigators, and we want Robert Yates and Ford and Multimatic and Chip Ganassi to partner and to take that engine and go back to Le Mans and try to beat Ferrari just like they did in 1966 and we want you guys to do that. So we started on that project. The F69A came in really handy. I mean, we had to machine a lot of blocks. That was a production block from Ford Motor Company. So we machined those blocks, built those engines, and ultimately went back and accomplished Edsel Ford's goal and Ford Motor Company's goal of winning Le Mans 50 years after they beat Ferrari. So what a fantastic story that we did together, and our partnership was critical. I mean, every one of those blocks was brand new. Basically, you'd run that production block one time, so they were constantly coming through and going through, and the machine just did a fabulous job for us. I mean, building engines is all about details, consistency, and the F69A really performed well for us.
Good morning, I'm David Bullock and I work at Robert Yates Engines. We're here today at Robert Yates Racing to show a few things on the Rottler F69. We can get started right now. We're going to do a little thrust cutting. We use this for boring, decking. We use it for some CNC operations, lifter bushing install, just about everything that you can do to a block. This machine will do in almost one setup. So very versatile, very time efficient. One of the main reasons that we got this machine was the accuracy. You can deck a block within less than a thousandths, both sides and both ends. You can bore these, like these main bores right here, you can bore it right to a number. Whatever you put in the machine, that's what it's going to do. Having all the engines the same is sometimes more important than the actual power numbers that you're looking for. You don't want to give one customer a motor that's any better than the other. So as far as repeatability on the power levels, to answer your question on whether they're all the same or is there some sort of tolerance between them, it would be very minute, way less than 1% from one engine to the other. Indicating, normally you would use your last word indicator and indicate just in the block, and with this you can actually just pick up 3 points in the block. In doing so, you find your zero for the block, and then in most cases you would just raise your spindle up a thousandths and make that be your Z axis 0. And of course at the same time you're also setting your Y0 at the same time. And then as far as getting the positions go, in this case it's just a simple matter of kind of crank over, and you don't have to really measure anything. You can just eyeball all this stuff. As long as your cutter will clear and your right angle drive will clear the other main, you can use that as your starting point, your zeros. And on the Rottler machine it's easy. All you have to do, you don't have to input any numbers. You can just push that set button right there and it records those numbers for you. And then manually you just go to the next one, do the same thing, come down, make sure you clear both main caps. You can hit your set button again. So what we're going to demonstrate right now is thrust cutting for the main surface on this RY45 block here. I've already lined the block up and got my zeros set to my main bore. We start out by determining how big the thrust needs to be on the OD and we can set our tool accordingly, and then measure the width of the main, and we input that on this page right here, and that gives you a starting point for your 0 on your X and your Y, and then you just determine how much you need to cut off. So in this instance, we're going to cut 1/1000 on both sides. One of the benefits of the Rottler F69 is you can cut both sides of the thrust with one setup. You don't have to flip the block around. Okay, so now we've got all our locations input into the machine. Everything is lined up, got our cutter set to the diameter that we want. So we're ready to go here. Just double check everything, make sure you're ready, and all I got to do is hit the auto cycle and we'll start cutting. The ability of this machine to be able to cut such a large diameter on that thrust face is it uses circular interpolation to reach out to those outer diameters there. The tool has to be able to pass through the main bore, and but then it's able to interpolate that surface after going through the mains itself. We finished our thrust cutting cycle on the F69 using the circular interpolation method as opposed to just a wide cutter trying to cut that whole surface. You get this perfectly smooth finish. For those of y'all that have ever attempted a line bore on a conventional machine and cutting that thrust surface there, or at least for me, always been a challenge to try to get a nice smooth finish. It's either chattering or it's dragging or the tool is deflecting because you have to have it hanging out so far from the spindle that you always encounter some issues. And in this instance on the Rottler, you don't get any of that, and as you can see, it's a nice smooth finish. One of the key factors in getting a smooth finish is using a single point cutter as opposed to a carbide with a wide face. depending on your material. This is just a commercial grade triangle carbide insert. You can get different radiuses on the corners, and obviously you know, when you do both sides, you're using 2 corners there, and it is indexable, so if you do chip one side, you can rotate it. The main reason that you want to just barely skim the block is to keep your cam crank center line as close to stock as possible. If you start cutting a lot of material out of the block and that distance decreases, you're going to have timing chain or timing belt issues or gear issues. Say a straight 6 that has gears with no chain, you don't want to get those too tight, so you really got to stay out of the block as much as possible. Depending on what's happened, I mean, sometimes if you spin a main bearing, it's going to mess the block up and you're going to have to take some material out. But this way you can control where you are cutting. It's not like you're just going back through the same bore and cutting equal amounts out of the cap and the block. Now we've got all our locations set, our distance of cut set. This machine here, all this stuff you can carry over to the next block if it's the same type of block. All your settings, all your locations will be in the same place. And again, with this type of equipment, each one of those bores is going to be the same diameter. You don't have to take the tool out, move down to the next location. Every one is going to be the same, and that's important because a lot of times in a conventional line boring machine, if you do have to move the tool, you got the chance of setting it up. You know, it might only be a half a thousandths, but this machine you can bore 2 sides. You don't have to take this to a line hone and add another operation to it. It does it all in one step here. And again, each one of these 5 bores will be exactly the same.
Hi, good morning. I'm Norris Marshall, President, CEO.
Great was that, seeing those machinists and machines in action, knowing that we're building horsepower, knowing that we're getting it right. I was just so excited, Embry. We're now going to do a Q&A. I told you, get your questions ready. I have the iPad, very stressed, don't want to drop the iPad. But that's probably the feeling you guys get when you're working on an engine block. You want to make sure everything is absolutely perfect so you can send it out the door.
Yes, we get a very gratifying effect when we know the job is done right, and the results are usually come out when the engine gets to go out and perform and do its task.
Exactly. So again, if you've got questions, put them in the chat, and we'll ask Embry, of course, from CNC Blockworks, about just any facet of what you just saw, how to do it. That's the whole point. There's no question. There's no question that Embry can't answer.
Well, there may be a few.
Exactly. Now, I do have a couple of seed questions, though, that regarding line honing. Like, do you need to line hone after line boring?
In my opinion, no. If you do the procedure properly, you finish the housing boards to the diameter that you have expectations of, then why would you need to take a chance and line hone? Every time I've line honed, it's always moved the center of the crank closer to the camshaft. If you're going to take that equivalation into it, then so do it. But if you want an offset number or a number specifically, then I try to not touch the bed of the crankshaft in the block and take it all out of the caps.
Excellent. All right, Kenny's out there, says, the major question I have is I have recently started hearing about 2 different RA finishes in a single cylinder. The advantage I've heard, this is Kenny, is about having a better oil retention where it is needed in the stroke of the engine. Is there any real truth behind that?
Well, at this particular time, I can't say that I know that to be a fact or not. When we finish our blocks, we also have the Rottler HS85A. We have the profilometer. We use those numbers by the ring manufacturers. So we control our oil with our honing process.
Oh,
I
excellent.
hope that helps him a little bit.
No, a little bit, I'm sure it does. Richard wants to know, just a general question, thank you, Richard, about the tolerances that these machines have. And he says tenths. Tenths?
Yeah, you actually can. I mean, we try to run everything as close to a tenth, top to bottom, from corner to corner. Key with the machine is to calibrate it, to begin with, to make sure that the numbers are right. And with the probing system the machine has included with it, you're going to be within tenths. And I can relate back in the 90s that we were lucky to get 5 or 6 tenths. So things have changed. It's just gotten more meticulous, I guess you may say.
All right, next question. Can you lift or bore from the cam location? I hope I've got that right.
Yes, you can. You can do that. You can. You can take the block. There's special fixtures that Rottler has to do just that, because we have that question sometimes. People say, how can you guarantee that you are putting the lifters correctly to the center of the camshaft? And we basically, ourselves right now, we work off of the mains. We know the number from the center of the crankshaft to the center of the camshaft, and then we compensate at that point. Whether we've got to move, if we're putting a 55 miller camshaft in it, if we have to move it up or move it down to guarantee that, we do that. But the machine also has the capabilities of boring from the center of the camshaft with the fixtures.
Are there any questions that we didn't get that you think is a valuable, important question that you'd like to put out there for folks?
I don't know if there's any questions that I could raise about the machine. If you asked me a year ago, probably so. But it takes time. It takes the willing ability to learn. It's especially, when you're an old dog in a new market, then sometimes you have to think outside the curve. And I got to say, the support staff with Rottler has opened my eyes up to a lot of new aspects and new views at looking on how to do procedures. And I compliment them on that. I mean, other companies that I've dealt with in the past, you buy the equipment and they're gone. And I love the support that Rottler gives me.
Well, that's tremendous, and it is the foundation. Now, I do have noticed some questions out there, people asking about, are we live? We are live right now,
yes.
And we're supplementing with some videos and performance chips along the way. But if you do have a question along the way, there are going to be multiple opportunities. We're going to have Chuck Lynch on in a little bit. We're going to talk with him. It's going to be a lot of fun as we kind of go through the process here at the Engine Performance Expo. It has been great, Embry, learning a little bit about the machine and what you do, and you taking the time to answer some questions. All right, I got one more in. What is the change over time from line boring fixturing to boring surfacing? Are the fixtures doweled or pinned? Are they doweled or pinned?
They're not really doweled or pinned. Again, that's where the setup, when you move the fourth axis off of the bed, at that point when you reinstall it, you need to index it. And that's what part of the Rottler probing system is all about. You can index it. You can check the 90-degree angle on the block. You can check the squaring across the top. All those factors have to be taken in. The changeover to me is basically maybe an hour, to get guaranteed that the left side of the axis is correct and you transfer it over to the right side. So yeah, it's traceable. Yeah, you can follow it that way.
And once you have the equipment, Rottler has people who can help you along with any of these questions.
They do, and I have to give them credit on that, because our salesman is Hal Fowler, and he's done an outstanding job with us. And we also have Mr. Keebler, who we can never thank enough, and they've got a great staff. They follow up, and actually, if I have a problem, I can get online, and they actually jump on the screen and start working through the computers, and they look to see what the procedures are, and next thing you know, boom, they call you up and say, okay, dummy, you did this wrong. Go back and fix it.
How often does that happen?
Very seldom.
Yeah, well, exactly. And that is why you are here. So keep those questions coming. Keep involved. Stay ready. We've got more coming up. Thank you very much, Embry. But right now, well, did we get him? Did we get Mr. Bullock? Oh, no, we're going to continue. We're going to throw it to a performance chip, but we'll be back with more here in studio at the Engine Performance Expo. What a day, what a day, what a day.
Yeah, my brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.